Hello, hello. This is chapter 9-10, quiz number 2. So I'm going to go over this one. Again, we want to know how many pi bonds this molecule has. So the thing to remember is every time you have a single, double, or triple bond, there is at least one sigma, where the bonding is directly between the two atoms. But if you have a double bond, there is also, with a double bond, there's a sigma plus a pi bond. And if there's a triple bond, there's one sigma overlap and two pi bonds. So since we have two triple bonds here, we have a total of 4 pi bonds. If we wanted to know the number of sigma, we'd count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or maybe that was 10, I don't know. But again, you only have pi bonds for double and triple. Keeping rotational versatility of these bonds into account, how many distinct isomers do we have for C2H2F2? So when you draw the Lewis structure, you'll find you have to have one double bond between the two carbons. And so then it's based on how many different ways can you arrange H2 and F2. Now with the double bond, whether you put the fluorines on the same side or the opposite sides of the double bond, will end up with different isomers. So you could have two fluorines both on the left, or if you put them both on the right, that would be the same. But then there's also the cis configuration where there's one on top, one on bottom, and then there's the trans. Well, that was the trans, and then the cis configurations is where you have fluorine. Both fluorines are on the same side of the double bond. So in total, there are 3 different isomers. What type of bonding is present in SO3? So here there's only nonmetals. You only have ionic between metals and nonmetals, and it's polar covalent when the difference in electronegativities is much greater, and nonpolar when the electronegativities are very, very similar. So since oxygen has a higher electronegativity than sulfur, it is a polar bond. And if you draw out a Lewis structure, this one has an expanded octet, but in every case, it's polar. So we would only have nonpolar bonds if there were oxygens bonded to oxygen, sulfur bonded to sulfur. But so these are all polar covalent. Talking about hybrid orbitals, we said the number of bonds of atoms needing to bond can tell you how many orbitals had to hybridize. So if this is phosphorus pentafluoride, there are 5 atoms needing to bond, then it needs 5 atomic orbitals needed to hybridize. So we always start with one S, and then we can go up to 3p. And that gives us 4. So if we're talking about just needing 4 bonds, it's sp3. But to get 5 after sp3, we go to sp3d. And then any further would have sp3d2, and so on. Again, here's another pi bond question. Again, anytime we have a double bond, there's a single pi bond, and with a triple bond, there's 2. And so for this one, we have a total of 3. The dipole moment increases as polarity increases. That's true. So just when we say something's polar, that's a qualitative statement. But the dipole moment is experimentally measured. It is the quantitative measurement. And it has to be experimentally determined. The only way you would really be able to guess what it is if it's perfectly nonpolar. And in that case, the value would be 0. For 7, which of these has polar bonds but is nonpolar? So first, it needs to have polar bonds. So anything bonded to itself, we can get rid of because that's not polar. And then the 2 on the bottom, those are both polar bonds, but the only way it can be nonpolar is if it's symmetric so that they cancel out. Here we have 3 chlorines, it's tetrahedral, so it's not superpolar because the chlorines are going in opposite directions, but it's not completely symmetric. And so carbon dioxide is the one that's completely nonpolar, where you can look up in the notes where I even use this example. There's 2 polar bonds going 180 degrees from one another. So even though it has polar bonds, the thing is nonpolar. Which of these molecules is polar? So we have methanol, water, and this is dimethyl ether. Now, all three of these share the same thing in common. They have an oxygen that has two non-bonding pairs that introduces a bent configuration. If you hear yelling in the background, those are my wonderful kids. So since each one of them has an oxygen making it bent, and each oxygen makes a polar bond with either bonded to carbon or hydrogen, then every single one of these is polar. Again, if you were to draw out the Lewis structures, none of these are highly symmetric, making them polar. Now, one of the properties I wanted you to know about being polar is it makes the particles want to stick together more. And so that in Chem 2, we talk about higher surface tension, which leads to water having properties like capillary action, but it also just has a abnormally high boiling point. And so the more polar something is, generally the higher the boiling point. So what you need to answer this question, which one is the highest boiling point, is which one is the most polar. And but since they're all with hydrogen, knowing fluorine is the most electronegative, we would expect it to be the most polar and then have the highest boiling point. Next, which of the following elements would most likely form a polar covalent bond with oxygen? So not pure covalent, which would be nonpolar, also not ionic. So any metals like magnesium and sodium, those will yield ionic bonds. Oh, and also aluminum. But then there's oxygen and hydrogen. So hydrogen bonded to oxygen, they have different electronegativities, so that would make it polar. If you picked oxygen, it would be a covalent bond, but oxygen bonded to oxygen would be nonpolar. Next, potassium nitrate is more soluble in water than in hexane. So we know that water, a universal solvent, is good at dissolving things that are polar and ionic, because polar things are partially charged, and we know like dissolves like. So yes, this is true. Hexane, by the formula, when you see it's only carbon and hydrogen, you should know it's nonpolar, and nonpolar things will only dissolve other nonpolar things. But since polar is on the way to ionic, so ionic is electrons completely transferred, polar is partially transferred. Again, they do interact favorably. How can we classify carbon and chlorine? Um, these bonds. So again, carbon has, you could look up the value. Carbon has a value of 2.4. Chlorine, on the other hand, has a value of about 3. So since the difference is around 1, we classify that as polar covalent. Again, you wouldn't really have to go and look up the numbers. I'd normally just want you to know, we would normally expect if it was metal and nonmetal ionic, if they're the same element, or if it's just two elements really, really close to each other, like carbon and hydrogen, then we would expect it to be nonpolar. Oh, 5 minutes left. I paused for about 30 minutes because my kids were getting really loud, so I'm running out of time. So that's polar covalent. Again, electronegativity, we talked about this trend in chapter 8. You just need to know that the trend increases up and to the right with towards fluorine, but the noble gases being the lowest. So if we want this increasing, the most electronegative is oxygen, then carbon to the left, and then hydrogen to the left of that with the lowest. Which of these is the most polar? Now, again, what you have to understand is that if even though carbon chlorine and carbon bromine bonds are polar, because they're tetrahedral, the dipole moments perfectly cancel. So these first two are completely nonpolar. So with one polar bond, these are both polar. And to differentiate the two, since chlorine is more electronegative than bromine, it would have a stronger dipole moment and it would be the most polar. Like dissolves like means that things with similar mass are generally soluble. That's false. Hopefully you know that instead of mass, this should be with similar polarity. Atoms in ionic bonds have relatively large differences. Yep, that's true. Again, if it's close to if the difference is close to 0, it's nonpolar, and if it's somewhere medium, it's polar. What's the number of sigma bonds? So if you draw this out, there's a single bond between hydrogen and carbon, and there's a triple bond between carbon and nitrogen. So there's two pi bonds, but with one single and one triple bond, there's still only two sigmas. So every single bond type has two sigma bonds. We want to put these in order of increasing dipole moment, which means put them in order from least polar to most polar. So on the period, these are all trigonal pyramidal. So knowing that nitrogen's the most electronegative, um, it's going to form the most polar bonds, and then phosphorus is below it on the periodic table, and arsenic is below that. So as the electronegativity of nitrogen to phosphorus to arsenic decreases, so does that polarity. With 6 bonds, you need 6 hybrid orbitals. So sp3d2. And finally, this bond is polar covalent. That's a big negative, because if it's bonded to itself, it's non-polar. So there you go. There is the rest of this quiz. Have a fantastic day.